Hello data friends. A KQL query set is a tool that allows you to execute queries, modify and display query results from a KQL database. You can link each tab in the KQL query set to a different KQL database and save your queries for future use or share them with others for data analysis. You can also switch the KQL database for any tab, so you can compare the query results from different data sources. My name is Kamil and this video is part of the whole series about Microsoft Fabric. This tutorial provides a brief introduction to KQL, Kusto Query Language, queries using Querysets, and the major differences between KQL and T-SQL when using Querysets. In this exercise, we will perform the role of an analyst who is tasked with querying a sample datasets of raw metrics New York City taxi cab rides that you pull summary statistics, the data from the Fabric environment. We use KQL to query this data and gather information to gain informational insights about the data. So at the beginning, when we open Microsoft Fabric here, we need to create a new workspace. But in my case, I have my workspace already created, so I can just choose. I'm going to select this real-time intelligence. My workspace is this one, MS Learn Fabric, and we'll be working with this. So now I'm going to create new database. I have my workspace. I'm going to create new KQL database. So let's click in here, and now we have this new way of selecting or creating or selecting new items that we would like to create. And now if we put the KQL here, we have only KQL data set, query set. So this is not exactly what we want to do. We want to create event house, which will allows us to create new KQL database. So let's click on this, and I will call this lab 12. So this is what you can do, or we can use one of the existing event house that I have already. And let me try to find this, filtering by event house. And this is my event house created. So I have this event house, I can create new database in it. So I will do that in this way. This is the previously used name, so I will use that with underscore, and it will be new database default. Okay, I'm creating this database, and in few seconds we should have this database available here with the query set, as you can see. So when I click on this query set, then I have one tab available here with some examples, how to use it, with some reference, with some links that you can learn from, how to use KQL language or how to use SQL language when executing the queries to the KQL database. Okay, we'll learn this a little bit, the basic things, but before that we need to ingest some data to our database. So let's go back to this, and now before I move on, I will switch this one lake availability of this database. I will click turn on. This doesn't matter, I don't have any tables right now at the moment. So my data will be available in one lake as well. Now what we can do, we can get the data. So if I click here, I have several options. I'm interested to get the data from Microsoft, some sample data. So choose this one, And in this case, in this scenario, we're going to choose this automotive operations analytics. This database contains about 900 megabytes, and this is about the New York taxi rides. Okay, so let's use it. When you select this, loading the data, actually it's copying the data to our KQL database right now, and it contains only one table. Let's go back to this in a few seconds. Okay, our table has been created. It's named automotive. Okay, we can see what kind of columns are there. As you see, plenty of columns here, like about 40, I would say. And then we see some data. Yeah, there's a histogram. There's a live view. We can refresh this. As you can see, we have original data, uncompressed, 950 megabytes, and compressed data in the storage. It's a little bit more than 300. So it's a pretty good compression ratio. And yeah, so this took several seconds, or like maybe up to 1 minute, to import this table. And it's ready to go. It's ready for us to explore this data and play with KQL or T-SQL with the KQL database. So let's click on this table and query table. Yeah, at the beginning we just show 100 records, which is very simple, and it's like this. Yeah, so the query has been generated for us, and it's like this. This is the table. Yeah, and then we have pipe character, which means we are carry on with this query and adding more commands. So this is still the same query. So we can execute this by clicking run, or clicking on the keyboard Shift Enter. So I can click Shift Enter, and then we have our results in less than 58 milliseconds. Kusto Query Language, KQL, is a query language used to analyze data in Microsoft Azure Data Explorer, which is a part of the Azure Fabric, Microsoft Fabric. KQL is designed to be simple and intuitive, making it easy for beginners to learn and use. At the same time, it's also highly flexible and customizable, allowing advanced users to perform complex queries and analysis. KQL is based on syntax similar to T-SQL, but with some key differences. For example, to separate commands in T-SQL you use a semicolon, whereas for KQL commands you will use pipe operator. We'll see that during the demo. One of the key features of KQL is its ability to handle large volumes of data quickly and efficiently. This capability makes it ideal for analyzing logs, telemetry data, and other types of big data. KQL also supports a wide range of data sources, including structured and unstructured data. Overall, KQL is a powerful and flexible query language that can help you gain insights into your data quickly and easily, whether you are working with Microsoft Fabric or other data sources. In this video, we will focus on the basics of queries against a KQL database using KQL first and then T-SQL. We'll focus on the basic elements of T-SQL syntax that are used for queries, including select, which is used to retrieve data from one or more tables. In the same time, KQL language offers its equivalent, which is project operator. Project operator allows you to specify which columns to include in your query output. Where is used to filter the data based on certain conditions. The same operator is available in KQL and allows you to filter data based on specific conditions. Group by, which are used to group the data by one or more columns and perform aggregate functions on them. Summarize is the operator available in KQL and allows you to perform aggregations such as count, sum, and average. The same things like group by can do. Order by which are used to sort the data by one or more columns in ascending or descending order. So let's start exploring our table in KQL Database. So let's click this Explore Your Data, and we'll be moved to the query set under this database. Okay, so let's see, this is example. As I mentioned, we need to update our table here. Our table is automotive, and now we can take 100 records from this table. Fine, then automotive, we can also count how many records we have in this table. So as you can see, 2.5 millions. Okay, we can do also something like summarize, but we'll go to this in a minute. So we started writing some first very simple KQL queries. So this is how it looks like. Let's do something more. Let's do some project, which will be actually select. Okay, so automotive, then pipe, and then we use project. Let me see what kind of columns we have here. I would like to select only two project, vendor ID and trip distance. Yeah, so with this I can also take only 10 records and execute this. As you can see, we selected only two columns from the automotive table. So this is how it works, how project command works. Next thing we can do, what we can do with this is renaming columns. For example, we would like to rename the second column and give it a new name. For example, more kind of intuitive or user-friendly. Yeah, so it will be trip distance. Yeah, so this is the way how you can rename the column in the output. Yeah, now we have our trip distance column. So this is how we can do it. Now the next thing is group by. How to use group by. So again, table as a source, and then we use summarize. This is the operator available in KQL language to grouping or aggregating some records. And then we will use rename also. I will use the new name for column, trip distance, equal, and function that I will use to aggregate. And which column? It will be trip distance. Okay, and we'll be grouping by pickup, borrow name. Yeah, this one. Now I would like to use also project and rename column. Which column? Pickup, borrow name. Let me copy paste this. So it will be borrow. And I would like to select as a second column this one, because in our stream we have the new column available already. Yeah, let's execute this, and we have our aggregated data, as you can see, executed in 60 milliseconds from 2.5 million of records. Now what we would like to do, because we don't like this kind of null values like this, we would like to actually replace this with some kind of user-friendly value. Yeah, so how to do that? We can use a case operator. So let me copy paste this query and modify this a little bit, adding one thing here. So for borrow, I would like to use case. So case would be like this: is empty, this column. Okay, or this actually it might be null also, so I need to check if also there's a null, because you know that the null and empty, which is empty string, is not the same value. Yeah, so if it's this or this, then I would like to put this, and I would like to put something like unidentified, okay. Else, because this is like our if formula, if that's non-empty or non-value or non-null value, then we would like to just present this value, and that's it. This is our first column, and this is our second column. Let's run this, and now we don't see any empty cell in the borrow column. This is how we can use case or is empty or is null functions. Great, so we know how to group by or summarize some data. We know how to select them or project them. We know how to use case to kind of cleaning the data in the fly, live. What we can do next? Next thing would be order by. So how to use order by? So I'm going to use the same query here. Let me just put here that it will be order by now. Yeah. So I will be using the same thing here. So we have the sum, we have project, and I would like to sort this by borrow. Right now we don't have this sorted by borrow, so sort by is our operator, and we need to just sort by borrow. That's it. And now our output dataset is ordered by the first column. This is how we can do that. Now we would like to, for example, use the where operator to filter out some data to focus on some subset of our data. How to do that? So let me put some comment here and copy the existing query. So I would like to filter it by one borough, let's say Manhattan. So of course I can do that here and say borough is equal man, but actually this is not good practice. So of course it will work, but this is not good practice because the filtering data should happen at the beginning. Yeah, so then it's much more effective working only on the subset of your data in here. But because we don't have this borrow column yet, because we rename it later, so we need to use the original column. Let's execute this, and now you see exactly the same results, with exactly the same or very close to the execution time in terms of execution time. But the thing is that we are working on a very small data set right now. It's only 2.5 million of records. So for KQL database, it's really like a nothing. Yeah. But if you have like a billions of records, so how you're writing this query might impact the performance significantly. Okay, so that was our kind of KQL, basic KQL skills, yeah, to execute some queries. Now we'll do exactly the same, but in SQL. So now, as I said, we are going to do exactly the same operations, but with SQL language, which you might be much more familiar with than with KQL. Okay, let's start. Let's start with some simple thing, which is top 100 records. So this is the SQL, select top 100, start from automotive, yeah, and let's run this query. So this is our results. Of course, if you want to count amount of records, there's a count function, so we can do exactly the same very easily. Now, we would like to select two columns, so instead of doing the project and take keywords, we simply use the standard SQL query, so top 10, and select the columns that we need to show in our result. So that's very simple. Now, the other thing, if we would like to do the rename of the column with the SQL, you can do this like that, yeah, and trip distance. Okay, so then we have our column renamed. So what next? Group by. So if we want to group by, we need to do a query like this, and let me explain this to you. So we are selecting column, renaming this as you saw above, and then using some function here of this column and renaming this as a total trip distance from this column, and grouping by pickup borrow name. So this is equivalent to what we saw of KQL query. And again, we have some empty value here, so we would like to use case command or operator to remove this empty or null values from the result. Okay, so how to do this case? So because it's this pickup borrow name, we can do when this is null or the same column is empty, then unidentified. Okay, else the original value. Okay, and as we have as already, we can remove this borrow. Okay, and then sum as it was previously, because we cannot just group by pickup borrow name, because we done something with this data. So we need to do exactly the same in here. So I can copy paste that. Now it should work. Something is missing. I missed the case here. So case should be here and case should be here. So now, as you can see, you see that the T-SQL or SQL in general is much more complex here comparing to what we saw in KQL. So bear in mind, if you don't want, for example, learn KQL language. Now, what is the next thing? We would like to order by the results by borrow. So I can use just order by command, and that should be it. This works like this, yeah. Now the last thing we would like to do is where. So the where, unlike KQL, our where clause would go to the end of T-SQL statement. However, in this case, we have group by clause, which actually required us to use having. Yeah, so let's copy maybe that to the new version of query. And now there will be group by and where. So we would like to add this where to the end, somewhere like here, but we need to actually use having because we have group by. So having borrow equal Manhattan. Okay, this should works, and we should have only Manhattan in our result. No, we don't have, so probably I make a mistake. Yes, of course. And now we have appropriate result. As you see, comparing to KQL, the whole query is a bit longer and more complex. Yeah, if you remember, we had only this with the KQL, nicely formatted, and I think, in my personal opinion, it's more clear comparing to what we need to write in SQL to achieve the same result. And that's it in this video. Thank you for watching, and let me know in the comments below where KQL database would be useful and suits perfectly in your project or organization. If you want to learn more about Microsoft Fabric, visit Microsoft Fabric community website, link below, which is fantastic knowledge hub for this product. And there's much more information. In the meantime, have a fantastic day and see you next time.